వీళ్ళు వచ్చినట్ట వీళ్ళందరూ ముగ్గురు అంతే కదమ్మా? ఓకే, నేను చూసుకుంటాను. Yes. Amma, are you able to hear me? 7010. Respond only. One of you please respond. 099. ఒకసారి ఆయన పిలవండి. అమ్మా 7010 మ్యూట్ చేసి ఒకసారి రెస్పాండ్ అవ్వమ్మా.
Yes, sir.
Are you able to hear me?
Yes, sir.
Wonderful. Thank you. Now, the last edition we were speaking about the environment. First, I have given you the introduction for environment, and then we talked about major subject water. Last class we talked about the various sources of water available on this Earth planet, like rainwater, river water, and then you have tanks, you have lakes, and then groundwater, you have shallow wells, the sanitary wells, the deep wells. So these are all the things, various sources of the drinking water. Now today we will speak about water pollution. That is our subject, isn't it? Environment means environment which is polluting our earth, water and air. These are the three things broadly, and we are interested in this. So first of all, what is a very important ingredient for the survival of any creature as human being? We first take the pollution, water pollution. Water pollution, what are the various causes? Water pollution, what are the various types of diseases that can occur? And then are there any laws or acts on this particular water pollution, to control the water pollution? And then finally, water purification. On these lines today we will discuss. When we come to the water pollution, water can be polluted sometimes even naturally. The reason being, the source of any water, particularly to supply a city or to supply a small town, etc. We have a water source. For instance, a metropolitan city, or for that matter, our own Visakhapatnam city, which is evolving city with a 25 lakhs of inhabitants population, we need water on a large scale. We need water on a large scale. Whereas once upon a time, when this particular Visakhapatnam is a sleepy fisherman's inhabitation, there used to be only Anglo-Indians living in the old city. They need a type of a sort of life which is privileged because they are representing the English people. We had, on the other hand, in Mursalava, we used to have Mursalava reservoir. Even till today, you can see it is there. That particular Mursalava's lake used to supply, purified supply to the old city. So what we understand here now, you see there is a source of water and it has a catchment area. How water gets stored there, it has got a lot of large catchment area around. You have seals, you have earth for kilometers of distance, where this much surface when receives water during the rain is a huge quantity which is getting trickled into this particular Mursalava and collected there. And that water is used to be purified and supplied to the Anglo-Indians in our city. So what happens now? When water travels through this catchment area, it can get contaminated by various ways like, you see, you have dust, silt, etc., clay, etc. So water can become turbid, number one. Number two, when it passes through, there are some dissolved gases like carbon dioxide, hydrogen sulfide can get into the water. And there may be some animal droppings, etc. You have a microorganism which can pollute the water source. Like that, naturally also water can get polluted. But are there any modern water purification system in those days? There may not be, but they have got their own method of this purifying the water. We'll come to a little later by slow sand filtration. That water was purified and people used to use the water. But what more bothering the human beings today is the human activity is the main cause for contamination of the water. You see, because of the industrialization and urbanization. Let us see what is this industrialization and urbanization. In 18th century, there was the industrialization in the entire Europe. And subsequently, it was also extended to other developing countries, just like India also. Then you have any industry needs a lot of water for its running, and then number two, it emits a lot of carbon emissions, and also it will liberate some sort of effluents which contains. The effluents are containing heavy metals, then calcium, magnesium, chlorides, and then pigments, and then dyes, various type of chemical pollutants. They are polluting the river water, and then water wherever it is a large quantity of water that's stagnating in a particular place as a source of water for the human beings. And the other thing is urbanization, where people migrated from the villages and get settled around the industries, where there is a lot of human activity producing a lot of human waste, and then particularly human excreta, which is not scientifically disposed. What happens is the surface washing will pollute the entire water storage tanks or wells, whatever it is. Even sometimes in the groundwater also gets polluted. So this is because of the human activity, there is a lot of pollution. And another one is, in spite of taking so much care, because in the modern days we have very effective public health infrastructure where the water is supplied to the exhaustive and very large network of pipes, underground pipes to each house and its habitation. But yet, even then it can get contaminated. The reason being, when it travels for a period of or a distance of kilometers, sometimes what happens is these pipes are rusted, and then there are pipe joints, there are cross joints, and then they run by the side of the sewer lines. Every possibility of contamination of the water is possible because of this urbanization. So these are some of the reasons how this drinking water source is getting polluted. And then you see, we need to know what are, just by theoretically we speak so many things, but ultimately you have to show it on the paper that what are the pollutants and how the water is those pollutions. How can we measure them? There should be some indicators, isn't it, to measure the pollution of the water. So while measuring the pollutants in the water, you have biological pollutants, that means microorganisms. You have to somehow try to collect them and grow in the particular media, what's called agar media, where the pollinators are growing. That's an indicator. Number two, there is a biochemical oxygen demand. There is hydrogen sulfide gas, carbon dioxide gas, which are dissolved. In addition to this, there are dissolved solids which are injurious to the human being beyond certain permissible limits in the water. So first of all, you must know what are the permissible limits and how to measure them. When you say that the water has gone beyond the water quality criteria and it is unfit for human consumption. So these indicators are highlights and sometimes dissolved oxygen in the water. You see, when there is microorganism, anaerobic microorganism, bacteria, and then this organic matter, which needs a lot of oxygen from the water, they take it and get disintegrated in the process of purification. But what happens is when there is no dissolved oxygen, then the biological process stands still, and still there will be some microorganisms which are critical to the human health. So we also estimate the dissolved oxygen. If the dissolved oxygen there means all the organic matter and this bacteria, etc., are clear from the water. So we also estimate the dissolved oxygen. Then this is, of course, is only theoretical importance over a length of period. These are actually, we are just mimicking the Western countries and European countries, just repeating like a parrot. But till 1974, there was no much action on the pollution of the water source. Whether there be human activity or industrial activity, how to control them, unless we have a categorical act, promulgated act, and then some sections, and who is accountable for that particular act. Those things were not there. Recently, in 1974, we have found promulgated Water Pollution Act, 1974. So what are the various provisions in this act is, so you have industries. With the industries, there are criteria have been decided by this pollution laws, They have formed boards, water boards, sewerage water boards in the center, in the state. See, recently we have been seeing this river water, the distribution of river water. There is some fighting, strife is going on between various states, upper states and lower states. Karnataka, Andhra Pradesh, Telangana. Now the distribution of water, a lot of fighting is going on. On the same line, see, those boards are also responsible to see that water is not contaminated by the factories or by human activity. So, according to this particular act, the punishment. So, such act from 1974 it is in vogue. Now, let's see what are the various diseases that can be spread by the contaminated water. You have biological causes, you have chemical causes. If you take the biological cases, all communicable diseases once upon a time very rampant. Wherever you see there are epidemics, and only public health activity is to control the epidemics. But today it is not the picture. Even in developing countries, of course, developed countries long back they have left this communicable disease respect to the drinking water, because their population is small and they are planned in such a way that there is only one system of water supply to the entire country at the point of consumption, that is at the house level. There is only one type of water, because sometimes they used to have two types of water. One is for the drinking purpose, another is for the ablution purpose and other household activities. But no, there are some disasters happen because of confusion. People sometimes use the water for not a potable water, which is meant for washing, and there are some diseases. That's why the water uniformly, only one system of water, one type of water that is thoroughly filtered, disinfected, and tested for all the dissolved solvents, and then microorganisms. And finally, when they come to the conclusion that water is consumable and then fit for human consumption, and that water only used to be distributed to the entire country. Whereas that is not the state in developing countries, particularly in India, where we have 1.2 billion population. And you know the requirement of the water nowadays, in particular in urban areas, we need at least 150 liters of water. Very huge quantity of water. So this is very difficult for us only to supply one type of water. Of course, we have also been following the same best practices, and they are successful. Yes, we are following. But the thing is, for public purpose, we are not able to supply round the clock, 24/7. We are not able to supply because that much water is not available for us. Source water, we have no that much source of water. And you know, the supply of water will use community. It needs a lot of planning, it needs a lot of engineering work, a lot of capital outlay for distribution of water lines, etc. So right now we are not in a position to supply each and every habitation 24/7. So what happens is, naturally, when there is no water, sometimes water in sewer lines, they suck the water to the negative and water gets contaminated. So like this, we have man-made pollution. If you take the biological causes of the diseases, you have viral diseases, you have bacterial diseases, you have protozoal diseases, you have elements diseases. You have, in the presence of aquatic host like cyclops, where they can transmit many worm-like disease. Take the viral diseases, you have viral hepatitis, you have jaundice, you have poliomyelitis, you have rotavirus in the case of the children, you have typhoid, you have cholera, you have gastroenteritis. If you take the this elementary diseases, you have tapeworms, you have roundworms, And then the intermediate host is a cyclops like that. They transmit as an intermediate host. It enters the human body, and then it causes diseases like guinea worm and fish tail, etc. Those are the diseases which biological nature they can transmit these diseases. Of course, to a large extent, we are protected from these water contaminated diseases today. But as far as the chemical pollutants, particularly the sulfur dioxide, carbon dioxide, heavy metals, pigments, so all these things can not only directly affect the human being. You see the wonders. We detect the water pollution in case of biological causes like organism of cholera. If there is a cholera, it will occur in a small area, number of cases. So immediately you can go and tackle that particular problem and try to study that problem. Ultimately, you will see that somewhere the pipe is disconnected, or is sucking some sewage, or there is a sewage pipe and then sewer and then water pipe junction box. They are crossing each other, and there is problem of contamination. So that is easy. That is easy. See, there will be some people, a few people, they may become sick. It's only morbidity nowadays. There is no death because of contaminated water. Epidemic, those days have gone. Still, there are some epidemics means there the public health is not at all working, and it's the most backward. Such areas are not there today. Since I have been working very interior villages, tribal villages. Of course, in tribal villages still there is possibility for this epidemics. But as far as the plain areas is concerned, villages, urban areas, metropolitan cities, we are not finding such type of huge epidemics anywhere today. The situation, but the chemical pollutants, you see, in a small scale. If you take now the cultivation, we are using fertilizers, we are using pesticides. Where they go? They are there with the food grains. You cannot separate them. There is no procedure where you can directly filter these chemical pollution from food grains. There is no such procedures. We have not evolved such procedure. So what happens is you may take some precautions like cleaning or exposing to the sun, etc. Whatever you may do, but chemicals will not leave the food grains. Those chemicals will enter in a small quantity into the human body, into the various systems like nervous system, blood, etc. They cause some incapacitation. Which cannot be easily recognized. You say there will not be any number of people. Even if you see the number of people, they are sporadic. One case from there, one case from there, one case from here. And you cannot come to a conclusion, you cannot link them, all of them, and show a cause that this is the cause. This is the industrial pollutant, this is the cause because of which this diseases occur. So that is the problem now, these chemical pollutants. Still people say one example even till today, because these effluents are let off into the ocean in some places, because a large body of water nobody will object. And even the factory outlets, effluents, are let off into the rivers, which is the main source of water for a number of cities, villages, towns along the course of the river, So this particular contamination, we are not able to stop. Other point is, whatever may be the aquatic animals, aquatic creatures, particularly fish, they thrive on this particular water. Ultimately, what happens is slowly it will be getting deposited in the body. When you consume these fish as a food, that will enter into your body in a small quantities, negligible quantities. So over a period of time, it will rise to a public health important problem. First in Japan, they found that there's some minimatus disease. Many people will be giving example for this. Mercury poisoning. All those people who are consuming the fish from that particular pond or particular area are suffering from neurological diseases. A very shrewd physician, somebody with a close work along with the public health person, he expressed the opinion that I am getting number of cases. When I asked them, they are all giving the history of consuming the fish from that particular location. Then they have conducted a study in that particular area where a factory is letting out its effluents into the river. It's a mercury poison. So like that today, the number of poisoning factors are there from the industrial effluents, from the pesticides, from the fertilizers, all these things. So gradually, we are experiencing the problem of the chemical pollutants. Now, the challenge, even for the developed countries, in supplying the drinking water and potable water is chemical pollutants. Isn't it? So these are the indicators by which you conduct this biochemical oxygen, then dissolved oxygen, turbidity, pH, dissolved solids. All these things we estimate regularly in a periodical way and see that the samples are conforming with the permissible limits. Then we allow people to use that water for drinking. Otherwise, with the help of this particular act, we can take action against them. And then, of course, the government in the form of local self-government corporations and municipalities are also responsible, where they can give some suggestion to them to catch hold of those people who are not treating the effluents with letting out the water because of the pollution spread of the diseases. So, this is in short water pollution. What are the various causes of water pollution? And then what are the various diseases caused by pollution, and what are the indicators by testing, which indicators we can confirm the water is conform to the standards, water criteria. So then we will move on to the purification of water. That's what we are interested in. Of course, this is all various things which are to be, it is a convergence of various departments. One department cannot do it. Because water, you have waterworks engineers, rural water supply scheme. Industrial side, there is a factory inspector, that is another department. Agricultural side, you have agricultural demonstrators. From health side, you have PhD medical officers. Like that, you have multi-sectoral activity. All the sectors should come together and try to build a type of response which is very promising in view of the health of the, taking care of the health of the people. So, of course, we are on the way and government is taking much interest in this particular. Apart from this, we should supply water of the purification. Water of the purification. Purification can be there on the large scale, purification is there at small scale. Large scale means, you take for instance, let us take our metropolitan cities. Even for that matter, even Visakhapatnam, Greater Visakhapatnam Municipal Corporation today, it is the obligation of the municipal corporation to supply potable water for the entire Greater Visakhapatnam Municipal City, the Greater Visakhapatnam Municipal Corporation City, which is 25 lakhs of people, and you know, what is the requirement of water in urban areas is about at least 150 liters of water a day. And when you calculate the water that is required for the 25 lakh people into 150 liters, comes in thousands of astronomically huge figure. That much water supplied means it is a very arduous task. People cannot do it. Manually, we cannot do it. We need a strong public health infrastructure maintained by the engineers, water engineers, and time to time testing by the public health specialists, and then taking action by the pollution control board. Then things fall in correctly. All the departments are responsible for maintaining this water supply. Anywhere in villages also, in the days of past, we used to have a tank or a well, sufficiently big well, and this is the foremost action responsibility of the village pradhan, or panchayat secretary, panchayat sarpanch, who are maintained. And those who are being maintained since long time, Quranic period also. So those water, it has to be filtered, it has to be disinfected, it has to be distributed, a distribution network is necessary, and it has to go to the doorstep of the house, or at least, if that is not possible, a public fountain for few number of families. So giving an equal opportunity for all of them and to have sufficient water. So for doing that, either it is water on a small scale, water on a large scale, you need purification, and essentially the procedures are almost same. First of all, you have to store the water for some time. Then you have to filter that water to remove all physical impurities. After that, you disinfect that water. Disinfect that water by various means. Then you should subject that water for biological tests and chemical tests, and indicators must satisfy that the water is fit for human consumption. Then you let out the water to the public distribution system. So when water is stored for some time, maybe 24 hours, in a big reservoirs, sometimes they wait for even 7 days, where the water is subjected to nature, there is sun. So some of the bacteria will die in that period. And whatever the physical, the silt, scum, small particles, planktons, etc., they will settle down at the bottom. Relatively, you have a clear water. Relatively, you have a clear water. And now that water is subjected for filtration. You have rapid sand filters, you have slow sand filters. The principle is the same, just I have told you, I will not repeat it again. These filters will have the various grades of layers of sand, bricks, and stones, etc. When water is strained with the pressure, from above to downwards. What happens is what trickles down after traveling all this filter. So during this period, what happens is the water is filtered from all the pathogenic organisms, all silks, come, etc., all these impurities. Then it comes as a pure water. Even still, it is only a 99% or 95 to 99% potability only, because still there are some organisms, particularly virus, bacteria. All of them may not be filtered. Still, they may be there. So that water is subjected for chlorination. In rapid sand filters, particularly in a city like Visakhapatnam, we have a very big plant where thousands of liters of water every hour they will be filtering the water, and that water is collected at a particular place. At a particular place, we call them the town service reservoirs, where that water is subjected for chlorination. Chlorination is a process whereby when you mix it with water, it liberates certain chemicals which are inimical to the biological life, creatures, bacteria, etc. When water unites with chlorine gas, chlorine solution, it liberates hypochlorous acid. There is a chemical reaction. We also have some small quantity of hydrochloric acid, but to a large extent, this hypochlorous acid and hypochloric ions. This hypochlorous acid is very active and it kills all bacteria, even virus, except in high concentrations only it can kill. Viral hepatitis A and other viruses are there. In high concentration, otherwise it cannot kill virus. Ordinary situation, virus cannot be killed. So that water is like that is chlorinated. Then we have number of labs everywhere in the city. That water is tested in the laboratory itself. For what are the parameters? We test for pH, we test for turbidity, we test for hydrogen sulfide, we test for minerals like calcium and magnesium beyond permissible limits. Then, if they are conforming to the standards, then I release the water. It goes to high-level reservoirs. You see, by gravity, they supply water to the entire population. It's not by the pump, it is not by the continuous use of pumps, mechanical pumps. No, it's not like that. The water requirement is calculated in certain area, how many houses are there, how many people are there, what is the requirement. We already know that 1 liters of requirement water is there. And they calculate the total requirement of water. And they install such number of high-level reservoirs which can supply the water substantially as per the requirement in the particular area. So, even that water by gravity even flows. First thing is we are not able to supply 24 hours into 7. Only few hours we can supply water. So what happens is at the consumer level, that is when water is collected by the people, unless that water is having residual fluorine at least 0.5 milligrams per liter, that comes to some 1 ppm, 1 parts per million, which is a residual fluorine which takes care of the subsequent contamination of the water by microorganisms. So further, we have public health staff. Every house they will be going in the morning in the municipal corporation and municipalities. We test the water from the pot directly. If it has some residual fluorine, all right. If it doesn't have residual fluorine, then immediately they will give a feedback to the water works department, assistant engineer. He will immediately increase the dosage of fluorine. So this is the procedure, how a potable water is supplied to the population. First of all, by storing, subject to filtration, then subject to chlorination or disinfection. Now the water is clear, barring the chemical pollutants. There are some chemical pollution like arsenic, heavy metals, which are carcinogenic. And as on today, whatever the system is, the public health infrastructure system, it is not able to take those things into consideration. That means we need upgradation of public health infrastructure. Nowadays, we are taking 500 milligrams of dissolved solids in a liter of water. Yes, and dissolved oxygen is present at the time of letting out the water for public use. We presume that all the microorganisms have been killed because there is still some dissolved oxygen is there. And only 500 milligrams, very little, because it is impossible to supply water without any dissolved solids. So it is not also correct, because water has nutrients, it has nitrates, nitrogen gas. They are nutrients, they are required for our body. You cannot supply water without nutrients. So those nutrients also will be affected if you further chlorinate the water. That's why we will not go for superchlorination. Superchlorination is a specific procedure which is recommended in certain situations. We will talk it later. Only certain situations, not always. So this is the distribution of water on a large scale. You see, when in small scale means household purification. Household purification. You see, in household purification, you can boil the water. Simply, if you boil the water, it's better. It is better than any procedure now we are following in public health infrastructure. I'm very sure. If you boil the water for 5 to 10 minutes and consume the water, which is at least from the bore water or municipal water, this is the best. And it is not possible for all the people, but because it needs some investment for the purchase of cooking gas or firewood, etc. People will not go for that. And more than that, people are habituated to drink cool water nowadays. Who will go for hot water? So boiling, though it is best, but certain circumstances it has to be followed in times of outbreak. Number two, you can have filters in your home, in your own house. There are backfill filters, and nowadays people are claiming that AquaGuard and then other purifier, excellent purified water. It has got even ultraviolet radiation which kills virus and water. If you take water from this AquaGuard, you will be free from all the diseases. How far it is true, there is no proper scientific study and confirmation. Because there are multinational companies, they can influence the government, and then, of course, definitely there is some action. Otherwise, people will come to know and stop using those gadgets. Still, there is some use with them. That's why household purification. Today, we are using the water bubbles every day. They supply 2 or 3 water bubbles as per the requirement. They collect some 10 rupees or 5 rupees from us. We are just believing that this water is subjected to reverse osmosis. It's free from all chemical pollutants or bacteria or biological pollutants. Is it true? No. Even here also there is no proper study. Just by observing, you can say that this reverse osmosis water supplied to the people is not adequate. Why? It is a very slow process. There is a preparatory process where you feed in one chamber raw water, and then it has to be filtered and goes to other side, other chamber. That water is fit for human consumption, of course, subjected to testing for all the biological pollutants, for all the chemical pollutants, then only we can confirm it. But you see, that plant which he has installed in his factory can filter water in few thousand liters. That's all. In the entire 24 hours, he works. He can only produce few thousand liters of water. But the way they are supplying to the people, it is thousands liters of thousand number of houses they are distributing. How? How can it be? It can't be. What they are doing is they are taking the groundwater, of course, probably deep tube wells, where you go beyond this second impervious layer, naturally, no bacteria, no virus can reach there. That's why they are biologically fit for human consumption water. But chemically, you are not sure. If it is a hard water, or it is a soft water, we don't know. Unless and otherwise we estimate the chemical constitution of the water. So that is a difficult process. Of course, we are not doing that, but simply we are using the water. So those things are there. And other in villages, we have open wells. And one of the most important functions of the PhD medical officer is to see at least once in a month, each village, go to the village, see the well, supervise the chlorination. You see, RX apparatus is a small, short question for you, but nowadays it is not it's become absolute, but still you have to know. It is because the principles of chlorination you understand. If you see the chlorine estimation demand through the RX apparatus, and what is free chlorine. So these things you will be able to understand. First of all, you will measure the quantity of water in the well by estimating the level of the water, diameter of the well, 3.14 into the d square into h by 4 into 1000 is equal to 1 cubic meter water. 1 cubic meter water contains about 10,000 liters of water, 1,000 liters of water. And 1,000 liters of water requires 2.5 grams of bleaching powder. And like that, they come to a conclusion, and then they chlorinate the water, and we leave for contact period of 1 hour, and people used to use the water. That was the procedure in the past they used to follow. But now there are no open wells, there are no sanitary wells, there are all deep wells are supplied by the chlorinated water supplied by the local bodies, municipalities. But theoretically, you must know these things. So these are the various ways how can we purify water. Just 5 minutes is there. I think I will show you some of the slides. I will show you filters. See, I just talked to you about the slow sand filtration in a tank in villages. You see, this is the bed. This is the filtration bed. Just now I talked to you. You see the coarse sand. You see the stones. You see the bricks. So this is the filter where water comes to this well, and this water is subject to chlorination. It is not rolling. You see, this is the high level reservoir where it is subjected to chlorination, and that water is supplied. That is, of course, we have already shown you. We have already shown you. If there is no time, I just skipping out. You see, just now I told you the contamination of water supplied through the pipes. You see, here the pipe is damaged and water is with a gush coming out like this. Probably this is the repair taken up by the municipality worker. He just applied some plaster of Paris, something like that. He left like this. what happens is when water supply is there, okay, there is pressure in the pump, no sewage water can enter. But as soon as the water is stopped, there is negative pressure and this water is sucked into the contamination of water. This is the principles of water chlorination. You see, this is the raw water. So this is been stayed for about 48 hours like that. All this come, etc., will come to the down. And then this is the underground, under water carriage system where the pure water comes like this. And ultimately, you will chlorinate that water. This is the filter bed. This is a very important thing. There is a final sand, coarse sand, stone, bricks, etc. Water is filtered through this. This is a rapid sand filter where once water is supplied to the metropolitan cities, this is a mechanical filter where water is pumped with the pressure, and then this goes through this filter bed, and the water is going perforated pipes. It comes out here, and then it is subjected to chlorination. Same thing in line diagram. And this is we are not finding it there. In our museum, it is there if you want. You can see previously people used to use the household purification water through these candle filters. This is a reverse osmosis. You see, people who are claiming aquaguard, etc., they send the water like this. These are ion exchange cartridges. When water flows through it, what are all the excessive chlorides, excessive acids, excessive minerals will be sucked and will be separated from that. We don't know. There is no any confirmation on that, any scientific studies. And this is the particle double part method. In olden days, there used to be jatras, etc., some sort of amusement functions, and days together, the jatras will be conducted. And during that time, wherever the nearby wells are there, they have to be chlorinated 24 hours. So for that, there is a procedure where we have coarse sand and bleaching powder mixed together in the inner part. This outer part has small pools like this. This will come as a short notes. That's why I'm telling you. And slowly, chlorine, bleaching powder will be coming out in the form of liquid. So continuously there will be chlorination in that well. So it will stop the growth of the bacteria, etc. So these are the things. So friends, two students are absent. There are only 5 students. Okay, and this is a very important topic. I have covered the topic in a way I could do to the best of my ability. I have also shown you some of the pictures, and I think I was the only person who took you long back into the Narava, right? The waterworks system is there, water filtration plant I have shown you, and then I have shown you dumping yard where leachate, how it pollutes the groundwater. One of the batches I have taken is the Marsala, where the slow sand filter, still it is working. That is the very interesting thing. Even till today, it is functional to see that. So that you will have required knowledge in the bottle. Because in primary healthcare, you see, you are the monitoring officer in the entire village. There may be waterworks department is there, sarpanch is there, secretary is there, village pradhan is there, and then you have gram sevika is there. And there are so many people, black development officer, the mandal development officer, RTO, there are so many people, but ultimately you will be held responsible for any epidemic in that particular area. You have to conduct an immediate investigation and try to fix the department which is responsible for this particular happening, and you should immediately inform the collector to take remedial actions. You are a very key person in that particular area. That's why you have to know about the function of these things, and you have essay question, you have short notes also. So we will stop here. In the next class, water quality criteria is very important topic. I will speak. I will end it now. Okay. And